Assalamu alaikum, grade 4. How are you? Hope you're enjoying your weekend, studying science, of course, for your assessment and other subjects. Okay, in this video, inshallah, we're going to revise what we taught the last week, lesson 2, about energy and its different forms and transformation and how we get it and so on. But before starting, let's say الدعاء. اللهم لا سهل إلا ما جعلته سهلا فأنت تجعل الصعب إذا شئت سهلا يا رب العالمين. اللهم إني أسألك فهم النبيين وحب المرسلين وإلهام الملائكة المقربين. اللهم إني أسألك قلبا خاشعا ولسانا ذاكرا شاكرا فأنت على كل شيء قدير. Okay, now let's start our session with a simple game. Now we're having this dog, as you're seeing, it's feeling cold and he needs some warm. It needs some warm. Maybe we can get it a heater, or maybe we can search for a source of heat energy to warm it. Let's try to open the curtain. Oh, the sunlight entered the room. The sunlight entered the room. So let's move this dog and the sunlight so maybe it will get some heat energy. Wow. Now the heat energy. Yes, the heat energy can feel warm now. Do you know why? It's because of the heat energy that came from the sun and warm it. Sun is the source of light and heat energy. The heat from the sun travels to earth by radiation. Yes, exactly. So now let's start. At first, we're going to start with the heat energy. Do you know what is that? What do you think? When I asked you in the class, you told me it's maybe a thermometer or something. Look at the screen. It shows different colors. Look here. Look, from different temperature. When the temperature gets higher, the objects become more bright or more orange or more yellow. So maybe these devices show us object with different temperature, and maybe it gives the objects with different temperature, different colors or something. We will know by the end of this session. Heat energy. How heat energy transfer from one thing to another or from one place to another? It transfers by something called conduction. Like for example, this griddle. We'll put it over the burner, and heat energy travel or conducted from the burner to the griddle, and then if you touch this griddle, heat energy will transfer to your hand, and maybe you will get burned. Okay. Heat energy. Heat energy is the energy that transfer from hot object to cold objects. Of course, it travels from hot to cold. Can it travel from cold to hot? No, because cold thing doesn't have heat energy. Hot things have heat energy. So heat energy travels from hot to cold, or from warm objects to cool or cooler one. Like for example, this woman, once it touched the iron, this woman once she touched the iron, her hand get burned because heat energy traveled from hot object, the iron, to her hand. What happened when you touch a hot object? Heat energy transferred from this hot object to your warm or to your cold hand. So heat travels from hot to cold. It transferred from hot object to cold one. Let's see, how did we cook this pancake. The burner has a lot of heat energy. It's really hot. So heat energy travels from the burner to the griddle and then to the batter or the pancake. So, is this a contact heat or distant heat? Did the batter get heat by contact, by direct contact, or from distance? Of course it's contact heat. What about the sun? How do we get heat from the sun? Should we hug it? Should we hug the sun to get heat from it? Should we hug the sun to feel warm? Of course no. It's a source of distant heat energy. So we have two different types of heat energy, contact heat and distant heat. The heat source in touch with an object, direct touch, is called contact heat, like when you're cooking or making fried eggs or something, when you cook something on the burner. And also distant heat, like the heater. You know the heater that warms the weather for us. Should we hug it or touch it to get heat? No, we just place it nearby and we feel it's warm. Example heater and incubation checks box. Let's see this incubation check box. What about this before seeing the incubation check box? What about this? This woman touches the iron directly by its hand or by her hand. So it touches by her hands directly. So is it a contact heat or distant heat? It's contact, as there is touch between the source of heat and the heated object. This is the incubation checks box. For eggs to hatch, it need heat energy. Normally, how eggs get the heat energy? From the hen or from the chicken that sit over the eggs and give it heat energy and warm it. Fine? But if we have a huge amount of eggs, a lot of eggs, and we want them to hatch fast, they put it in something called incubation heat box. This incubation heat box, they light lamps in it, so those lamps give eggs heat energy so eggs hatch quickly. What about melting some marshmallows? Did you put marshmallow inside the fire to fry them or something? No, you just place them a distance. So this is distant source of heat energy, distant energy, and also this is distant energy because we are not putting the lamp in direct contact with the eggs. We just place it nearby. Heater is also source of distant heat energy. Temperature. What's temperature? Temperature is how hot or cold an object is. If the object is hot or cold, this tells us about its temperature. But how can we measure the temperature? How can we measure it? We can measure the temperature using a device called thermometer. We use the thermometer to measure the temperature, to measure how hot or cold an object is. Which one of those thermometers show the highest temperature or the highest energy or the highest heat energy? A or B or C? Of course it's C, the last one. It shows a high temperature, maybe 35 degrees Celsius. 35 degrees Celsius. We use thermometer to measure temperature. We talked about this device at the beginning of the session. Now you should know what is it, but through watching this video, we will send it to you inshallah, but actually I can't turn it on here because of the copyrights. But this is thermal imaging device. Thermal imaging device. It takes photo for objects and give the objects different colors according to its temperature. Who use it? The firefighters use this thermal imaging device. Why? To see cooler bodies through hot smoke and rescue people from fire. When there's a fire, there's a lot of smoke and firefighters cannot see people to rescue them. So they use this thermal imaging device to look inside the house and know if there is a live human through its body temperature. It just gave different colors for human body temperature. Like here in the book at page 94, it said, it's helped the firefighter to rescue people and pets from fire. How? As it gives different colors for objects with different temperature. In session 2, we talked about light energy. Light energy, or electromagnetic spectrum. What is the main source of heat and light in our Earth? It's the sun. The sun is the main source of heat and light energy in our Earth. Why do we use solar panels? Do you know the solar panel? This is the solar panel. Have you ever seen one placed in a farm or over a house or in a calculator or a toy that you have with this black sheet, the solar panel? These solar panels take energy from the sun, the light energy, and they transform it to electricity. So we can use it in our home and turn on different devices or make the non-living things move and give us different forms of energy. So these solar panels take the solar energy or energy from the sun or the light energy from the sun and transform it to electricity. So we can use it at our homes or farms and so on. Electromagnetic spectrum. Electromagnetic spectrum are the waves or the light waves that came from the sun. Can we see them all? Can we see all of the light that came from the sun? Can we see all of the electromagnetic spectrum that come from the sun? Of course no, we can't see them all. Allah subhanahu wa ta'ala gave our eyes certain ability. And this ability let us see specific energy, a specific range of energy, a specific range of energy of those electromagnetic spectrum or of those light waves that came from the sun. And we call this portion which we can see visible light. Visible means can be seen. It came from vision and able to be visioned or can be seen. We can be seen as very small portion of the light that sent from the sun to earth. And we call it visible light. While the other forms of light wave that sent from the sun, we can see. We can see, have you ever seen a microwave? Have you ever seen infrared, X-ray, ultraviolet? We can see all of those different forms of light energy that came from the sun. We just see the visible light, this portion, or the white light that we can see it coming from sun. And this white light composed of 7 colors, which are the rainbow colors. So as we said, light waves that came from sun are either visible or non-visible. The visible light waves are the visible light wave are the white light that we see coming from the sun, which consists of 7 colors of rainbow. If we take the first letter from each color, we can make the word Roy, Gab, IV. Roy, Gab, IV. Red, orange, yellow, green, blue, indigo, and violet. Okay? Violet, the last color, have the highest energy of them all, while red have the lowest energy of them all, the biggest color, the biggest letter and the smallest letter. Violet have the highest energy of them all, while red have the lowest energy of them all. What about the non-visible light which we can see, like the radio wave and microwave and ultraviolet waves and X-ray? We use all of them in our daily life. We experience all of them in our daily life. Like for example, the radio waves. The radio waves are sent to our radios, antennas, so we can hear different stations on radio. Microwave, we heat food using it at our home, and there's another usage I will tell you about it later. The ultraviolet wave, if we keep sitting in direct contact with sun, maybe we'll get some skin burns. Those skin burns from the ultraviolet waves. And by the way, some insect can see the ultraviolet waves. Some insects, Allah subhanahu wa ta'ala gave them the ability, gave their eyes the ability to see the ultraviolet wave. We don't have this ability. And also X-ray, we use it to scan our bone and teeth, for scanning bones and teeth, and it's a very, very powerful light waves. Let's see who is the strongest and which one is the strongest and which one is the weakest. At page 96 and 97, you will find the energy scale of waves, starting from the lowest energy to the highest energy light wave. Radio wave is the lowest energy waves. It's not harmful at all. It's the lowest energy one of them. Then came after it the microwave. Number 2, the microwave, that we use it to heat food and maybe for weather broadcasting images, and I will show it to you right now. And then the visible light between them all, in the middle, the visible light that composed of the 7 colors of rainbow, which we can see, the visible light, the white light, which we see it coming from the sun, which consists of the 7 colors of the rainbow. Roy gave IV, red, orange, yellow, green, blue, indigo, and violet. Then the ultraviolet light. And by the way, you know NASA? NASA is a very big organization, space organization actually. They place a telescope in the space called Hubble telescope. This telescope takes some pictures for the ultraviolet light, and they will show it to you right now. And if we keep being exposed to ultraviolet light, maybe we'll get skin burns because it's more powerful than visible light and the microwave. The strongest of them all is the X-ray, which we use it to scan our bones and our teeth. This is the image I told you about from a while. This is the image took by Hubble telescope, the telescope that placed in the space, and it shows the ultraviolet light, which we cannot see by our eyes while some animals can, some insects specifically. And these are the weather forecasting. They took this image using microwaves. They made these images use microwave to make the weather forecasting. And also those images for weather forecasting using microwaves. Some insects can see things different. I can see the corridor in this way, while the fly can see it in this way. Do you know why? Because it can see the ultraviolet light waves. It can see the ultraviolet light waves. Guess the type of the invisible light that used here. The X-ray, sure, excellent, super. If we have a scale from lowest energy to highest energy, so which one is the lowest of them, of the electromagnetic waves or the light waves that came from the sun, which we talked about from a while? Radio wave is the lowest energy of them. Microwaves came in the second level, and we use it for heating food and for weather forecasting. In the middle, the visible light, only the energy portions that Allah subhanahu wa ta'ala give ability to our eyes to see it. The white light, which we see it coming from the sun, that consists of 7 colors of the rainbow. Ultraviolet, more energy. If we keep exposed to these rays, we may get, or these waves, we may get skin burn. And the X-ray, the most powerful of them all. In session 3, we talked about sound energy. Sound is also an energy, or a form of energy. How do you think sound is produced? How do you think sound is come? Sound is produced by vibrations. Sound produced by vibration. But what is vibration? Vibration is a backward and forward movement of an object. Back and forward movement, very fast. This is vibration. is the energy that travel in so sound is the energy that travels in vibrations, and vibration is backward and forward movement of an object. So how we make sound by our mouth? There is something called vocal cords in our throat. Put your hand on your throat and talk. Say ah. Put your hand on your throat or on your neck and say ah. Can't you feel the vibration? This is the vibration of your vocal cords. Your vocal cords vibrate, so this vibration came out of your mouth and vibrate in air and reach others' ear. This is the sound of a driller and kids whispering, which show us loud and which show us soft sound. Of course, the drill show loud sound because this man and the drill exert high amount of energy, while those whispering kids exert very small amount of energy. So the higher the energy an object has, the most its speed. If the energy is high, if the object has a high energy, it moves faster. The higher the energy, the more its speed. Let's look at those pictures. It's in the book. A plane, an aeroplane, moving. It makes sound. Is it soft or loud sound? Of course it's loud, super. And loud sound has high or low energy? It's high energy, super. A mouse that squeak, 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 squeak. A mouse makes soft or loud sound? Soft, super. Does the soft sound has high or low energy? It's low. Fireworks, pom, 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 pom. Okay, fireworks give sound and light energy. Is this sound soft or loud? Loud. Which have high or low energy? High energy. A gentle breeze from an open window can cause curtains to move. Curtains moving like this make soft or loud sound? Soft sound, super. Which has high or low energy? Low energy. Dripping water, tick, 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 make sound. Is it soft or loud? Soft sound. With high or low energy? Low energy, super. Sound can travel in solid, liquid, and gas. If you put your ear over the table or over the desk and hit it, you can hear the sound. That means that sound travels in solid. And if you keep hitting it while you're not putting your ear on the table, you can also hear the sound. But sound can travel in different speed in solid than in air than in water. Have you ever heard about someone that heard the sound of the whale in the Red Sea or in certain oceans? This is an evidence that sound travels in liquid. When you talk underwater, didn't you hear the sound? Maybe it's unclear, but you hear it. You hear blah, 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 blah. But this is a proof that, or an evidence that sound travels in liquid. And when you talk in air, like I'm talking right now, can't you hear my voice? You're hearing it because sound can travel in air or in gas. And it also can travel in solid, as I told you. Solid particles are very, very close to each other. So the vibration of sound, when it's moving through the solid particles, those are the particles of solids that are very, very close to each other. Particles of liquids that are a bit away. Particles of gas that are very away from each other. When the sound vibrations trying to move through these solid particles, it moves very fast because the particles are very close. While in case of liquid, particles are a bit apart, it moves slower than in solid. It takes time to reach different particles. So it moves slower than in solid. What about the gas? The particles are very away from each other. So the vibration reaches these particles. Then it takes time to reach this and this and this and this and so on. So the vibrations takes time moving in gas. So Gas is the slowest material through which sound vibration can pass or travel through it. So which is the fastest of them all? The fastest of them all is the closest of them all, which is solid. Sound travels the fastest in solid, medium in liquid, as the particles are a bit away, and slowest in gas because the particles are very away from each other. Now we finish our revision. Hope you understand every point clearly. Thank you so much for listening to the video. And now go to answer your assessment. I hope it helped you. Assalamu alaikum wa rahmatullahi wa barakatuh. See you next video, inshallah.